Hello friends, let's discuss PyTorch. PyTorch is an open source machine learning framework based on the Torch library, which is also an open source machine learning library, a scientific computing framework, and a script language based on the Lua programming language. PyTorch is based on Python and Torch and is mainly used for applications using CPUs and GPUs. PyTorch is primarily used for applications such as computer vision and natural language processing. Computer vision is a field of artificial intelligence that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs, and take actions or make recommendations based on that information. And natural language processing is also a branch of artificial intelligence concerned with giving computers the ability to understand text and spoken words in much the same way human beings can. Now let's understand the use of PyTorch in computer vision. In this case, I am taking an example of self-driving car or driverless car. In driverless cars, it uses a combination of sensors, cameras, radar, and artificial intelligence to travel between destinations without a human operator. That's why it is known as driverless. In this case, machine learning algorithms allows a car to collect data on its surroundings from cameras and other sensors, interpret it, and decide what actions to take. Typically, this self-driving system goes through 3 stages to perform its driving, and these 3 stages are sensing, understanding, and control. In the first stage, that is sensing stage, cameras and various sensors are used to see objects that are around the car, such as other cars, humans, traffic lights, trees, animals, bicycles, etc. So you can say it's the eyes of the car, which is constantly seeing everything around it, that is 360 degrees. In the next stage, that is understanding stage, various AI algorithms, mainly computer vision, is used to process the information from the sensors. For example, we might have one computer vision system that processes the video coming from the cameras around the car to detect all of the other cars on the road around it. Such a system would ideally be able to detect where the cars are, how big they are, and how fast they are and which way they are moving. In reality, these systems are designed to map out the entire environment around the car. All of this information will be fed into the next stage of the driving, that is control stage. So, the understanding stage is known as the brain of the system. It's where most of the major processing takes place, and the goal of this stage is to gather all of the information that came from the sensors and interpret it. In the final stage, that is control stage, the self-driving system will process all of the information that the computer vision system was able to extract, and based on that information, it will control the car. By knowing about all of the surrounding environment, what's around the car and how it's changing, the job of the control system is to move the car safely and towards its destination. It activates the brakes if the car in front is slowing down, switches lanes if it needs to exit, and turns on the wipers if it is raining. As in this case, as a man steps on a crosswalk, automated car stops before him. That means visualization of safety features. Another example is in face recognition. Face recognition system is built to identify a person from an image or video. It is highly useful across many applications and industries. These include unlocking phones, you all have used this feature, finding missing persons, tracking student or worker attendance, recognizing drivers, monitoring gambling addictions, and many more like this. How this face recognition system works? First step is the face detection. The camera detects and locates the image of a face, either alone or in a crowd. And in the next step, that is the face analysis, an image of this face an image of the face is captured and analyzed. In the next step, it converts the image into the data and then finds a match. I think it's clear to you. Let's gather some more information on this useful library. It was developed by Facebook's Artificial Intelligence Research Group along with Uber's Pyro software for the concept of inbuilt probabilistic programming. It was created as a successor to Caffe2, which is also a deep learning framework, and released under the modified BSD license. And this framework is written in Python, C++ and CUDA. Many companies, as you can see in this picture, are using PyTorch. Major PyTorch applications are in style transfer, image classification, handwriting recognition, forecast time sequences, text generation, driverless cars, as already I have explained you, and many more. PyTorch is favored over other deep learning frameworks like TensorFlow and Keras since it uses dynamic computation graphs and is completely Pythonic. Dynamic computation graphs means that graph is built up dynamically, means immediately after we declare variables. Dynamic graphs are flexible and allows us to modify and inspect the internals of the graph at any time. And Pythonic concept is what? PyTorch is Pythonic, which means that Python developers should feel more comfortable while coding with PyTorch than with other frameworks. Last very important question is why to use PyTorch? As computational graph support at runtime, it is flexible, faster and provides optimization. It has support for the GPU and CPU. It is easy to debug using Python's IDE and debugging tools. Here is the chart which is showing you the important dates and names which are very important to the PyTorch developments. That's all in this lecture. In the next lecture, we will talk about the features of the PyTorch. That's all we have in today's lecture. Thank you. That's all.